So binary search on a list is quite interesting. What it will do is it will look through and it will return the zero base index of the item in the sorted list if the item is found. Otherwise, a negative number that is the bitwise complement of the index of the next element that is larger than item, or if there's no larger element, the bitwise complement of count. So what does that mean? So let's go ahead and, so we have our sorted list here, and we're searching for 42. And in this case, 42 is found at element 2. Let's say that we want to search for some arbitrary number. Let's just do 84. So we know, looking at this list, that 84 does not exist, and it is between 42 and 91. Again, this is a sorted list. It has to be a sorted list. So for binary search to work, it has to be sorted. So we know that if 84 existed, it should be right there. So this would be 0, 1, 2. So this would be at index 3. We run this, binary search is going to return a negative 4. So let's go ahead and modify this a little bit. Let's go ahead and do int find index is equal to this. So instead of just printing it out, I'm just going to store it into an integer. So I'll do find index there. So now when we run this, we're going to get the exact same thing printed out. But if you look at the documentation here, if it will pull it up, a negative number that is the bitwise complement of the index of the next element that is larger. So C# and most other languages, you can put a tilde in front of variables and it will do a bitwise complement to that value. So now if I run this, instead of a negative 4, we get a 3. 0, 1, 2, and it should be at 3, but 3 is going to be the next one. So if we search for a number and that number exists, we can return the index of it. But if it does not exist, we can say, hey, we want to actually add that number into our list. So we can go ahead and say if find index is less than 0, means it did not find anything. 0. So if it is less than 0, console.write line failed to find item, find index is find index, just for debugging purposes. And now we can use insert. So we can say my nums.insert, and insert inserts an element into the list at the specified index. So we want to insert 84 at index 3. 91 is currently at index 3. We want 84 to be 3, which will mean 91 will become index 4. So we can say insert 84 at, or that's supposed to be the index. Sorry, I forgot my the order for all of this. So if I parentheses, and this will say we need an index and then item. So now instead of just putting find index, because that is a negative number, we want the complement of find index, and we want to insert 84. So now if we print our list afterwards, just calling the same print list, so we're printing the list, we're printing that we failed to find the index, so it'll basically print out negative 4 there, and then we'll print out the list again with 84 in the correct position. So there is the list without 84. Didn't find it at index negative 4. And notice that our new list has 84 inserted between 42 and 91, exactly where it needed to go. And so using this complement and this binary search, we can easily find the location where it should go, and then we can just insert that element into that location and still maintain the sorted order of everything. So this is an easy way to, you can prompt for a whole bunch of numbers, and every time that you add a number, You can do a binary search. You can see if that number already exists. If it does not, well, you insert it into the correct location. Otherwise, you may print out, hey, you already entered that number before, try again, or some combination thereof.